Find the exact value of sine of inverse tan 1/2. In example 1, we're looking for the sine of an arc whose tangent is equal to 1/2. Now, for any angle theta, if tan theta is equal to 1/2, it means that the side opposite to theta is 1 and the side adjacent to theta is 2. Placing those numbers in the reference triangle, we get c squared equal to 2 squared plus 1 squared. C squared is equal to 5, and c, the hypotenuse of the triangle, is equal to 5. Now we need the sine. We need the sine of that arc whose tangent is 1/2. The sine of theta will be the opposite, 1 over the hypotenuse square root of 5. When rationalized, the sine of theta will be square root of 5 over 5. We can answer the question now. The sine of an arc whose tangent is 1/2 is equal to square root of 5 over 5. Find the exact value of cosine inverse sine -1/3. It means we are looking for the cosine of an arc whose sine is equal to -1/3. Now, we need to remember that inverse sine is defined largely between -pi/2 and pi/2. We also need to recall that between -pi/2 and pi/2, sine is negative in the fourth quadrant. So sine theta is equal to -1/3, and it's located in the fourth quadrant. The opposite side will be -1, and the hypotenuse, which represent the radius, is always positive, is equal to 3. 3 squared is equal to x squared plus -1 squared. 9 is equal to x squared plus 1. Taking 1 from both sides, 8 is equal to x squared, and x is equal to square root of 8, which when simplified become 2 square root of 2. We will replace x in the reference triangle. X is equal to 2 square root of 2. Then we can calculate cosine theta, which is equal to adjacent 2 square root of 2 divided by the hypotenuse 3. Now, in conclusion, the cosine of the inverse sine of -1/3 is equal to 2 square root of 2 divided by 3. Find the exact value of sine inverse tan 1. Means the sine of an arc whose tangent is 1. The arc whose tangent is 1 from the reference triangle 1 square root of 2 is pi/4, and tangent pi/4 is equal to 1/1, which is 1. So the sine of pi over 4 will be opposite over hypotenuse, 1 over square root of 2, which when rationalized becomes square root of 2 over 2. In conclusion, the sine of an arc whose tangent is equal to 1 is square root of 2 over 2. For number 2, we're looking for the cosine of inverse sine square root of 3 over 2, which means we are looking for the cosine of an arc whose sine is equal to square root of 3 over 2. From the reference triangle, 1, 2, square root of 3, pi over 3 has a sine of square root of 3 opposite over 2 hypotenuse. Now, we need the cosine of pi over 3. Since pi over 3 is in the first quadrant, we can take the cosine and that'll be our solution. The cosine of pi over 3 is 1 over 2, adjacent over hypotenuse. In conclusion, the cosine of an arc whose sine is square root of 3 over 2 is 1/2.